All right, so we're ready to begin the free response section of exam 2. And we have this problem here, and I just want to sort of be clear on something. Object A is this guy here, this kind of flat line that you see along here, that's object A. And then object B is represented, its motion, its velocity as a function of time is represented by this slanted line here. And so we have our axes starting from here, starting like from here and just kind of going straight down. So there's one axis, and then the other axis goes out to like here along. So there's our time axis kind of right there. I think that was confusing people, so I want to be clear on that. Now, what we want to do is we want to compare different things. So first, let's compare the displacement from t equals 0 to t equals 5 seconds. Well, if you remember, the displacement, when you have a velocity versus time graph, that's the area under the curve. So for object A, let's actually get its displacement, delta x. So delta x for object A is going to be its area, and that's going to be 4 times 5, because the height's 4 and the base is 5, it's a rectangle, and that's going to be 20 meters. And then for object B, when we do its displacement, that's going to be 1/2 base times height, because it's a triangle, and that's going to actually work out to be, when we do our math, we're going to get a little bit of a different calculation, but let's see what the answer turns out to be. When we do our calculation, that's going to be 1/2 times the base, which is 5, times the height, which is 8. So that works out to be 1/2 times 40, which is also 20 meters. So they're the same. So how do we know? Area under curve is equal. So they're equal areas under the curves. Now, the average velocity from t equals 0 to t equals 5 seconds. What's interesting about that is the average velocity is displacement over time. We're talking about the same displacement, so therefore these are also equal because of equal displacement. Now, instantaneous velocity at 5 seconds, let's compare that. At 5 seconds, object B is at 0 and object A is at 4. What that means is that object A has a bigger velocity, and I saw that by reading the graph. Okay. Now, let's look at the acceleration. Well, the acceleration is the slope of the velocity graph. So A has an acceleration of 0. B, when we get the acceleration of B, that's going to be 0 minus 8 over 5, which is going to be negative 6/5 meters per second. So here's what I did just to be safe. I said that if you do absolute values, the absolute value of the acceleration of A is less than the absolute value of the acceleration of B, because what I said is that B has a steeper slope for B. So that takes care of that free response question. Okay. Now, next question. We want to know what the initial velocity on this graph. So we have a graph, we're going to analyze it, and let's get some calculations done. So we want to know the initial velocity. If I look on this graph, it's going to be 70 meters per second. When is it not moving? That happens at 7 seconds, okay? Now, what is the acceleration of the object? We get that from the slope. So that's going to be 70, I'll start here, minus 0. Actually, you know what? It's final minus initial, so let me be careful and do that right. The final velocity here at 7 seconds is 0, and the initial is 70. And we're going to divide that by the time that passes, so that's going to be 7 minus 0. So again, if you wanted a formula, that would be V final minus V initial over T final minus T initial. So when we go ahead and calculate that, we're going to end up getting negative 10 meters per second squared. Now, we want to know what the displacement of the object is from 0 to 7 seconds. I'm going to do this by getting the area under the curve. So that's going to be 1/2 times base times height. Remember, that's what we do to get area. To get displacement, it's the area under the velocity curve. So that's going to be 1/2 times the base, which is 7, times the height, which is 70. And so that actually ends up being 35 times 7. And I actually end up getting, if I have this right, 5 times 7 is 35. 3 times 7 is 21 plus 3 is 245 meters. Now we can actually check that answer by doing the calculation a little bit differently. We can see v squared equals v naught squared plus 2a delta x. So let's plug in those numbers. We're going to get 0 squared equals 70 squared, my initial velocity, plus 2 times negative 10, which I get from here, times x minus 0. So that's just x. So then we end up getting 490 divided by 4,900 divided by 20. That's going to be x. And when I do that, that's 490 divided by 2. And that also equals 245 meters. So all I did is, this is one method, and this is a second method. And they get the same answer. So 2 methods, same answer. You can use either one you want on the final. So now here, what is the initial velocity of this object? When we check, that initial velocity is going to end up being 20 meters per second on the graph. When is the velocity 0? Never. Now let's get the acceleration of this object. So this is about 90 right there, and that's 20. So let's do our math. We're going to have 90 minus 20 divided by 7 minus 0. So we get 70 divided by 7. And again, this is v final minus v initial over t final minus t initial. So this ends up giving us 10 meters per second squared. Once again, great. Now, we want to know the displacement. Here, if you're going to do the area calculation, you've got 2 areas to worry about. You have a little rectangle and a triangle. So we're going to worry about both of those things, so let's be careful. The height of the triangle part, if this is 20, is we have a height of 70. So we got to be really careful with our calculation. So our area is going to be the triangle plus the rectangle. So that's going to be 1/2 times the base, which is 7, times the height, which is 70, plus the area of the rectangle, which is going to be 20 times 7. So when we do that math, that's going to actually end up being 7 times 35 plus 140. So we get 5 times, so 245 plus 140. And so we end up getting 385 meters. And you can actually do it the other way, but I'm not going to actually do that now, the way that I did on this page. You can also do this calculation to check it out. And of course, for V, you'd end up, let's just check real quick. You would end up putting in 90 for the final. Here, you put 90, and you put 20 for the initial there. And you'd use positive 10 for your acceleration. So that's pretty good. Now we have a few more problems to do, and let me just check on how much time we have. Okay, so we got quite a bit of time. So let's go ahead. An electron has an acceleration of 3.2 meters per second at a certain incidence velocity is 9.6. What is its velocity 2.5 seconds later? So that's v equals at plus v naught. So that's going to be v equals 3.2 times 2.5 plus v naught, which is 9.6. So we actually go ahead and do that calculation, and we'll get our answer, which is, that works out to 17.6 meters per second. Now here, you know what? This problem, I actually ended up throwing it off exam 2, or like not counting it, because it was actually set up a little bit weird. So what I did was I crossed it out. So don't worry about studying that one for the final. I used some wrong numbers there, and it just doesn't make any sense. We're not going to worry about that one. Now, for number 6, and let's just see. We got 2 more questions, so that's good. We have a key that falls from a bridge 45 meters above water. So here's our key. And then there's the water. And basically what happens is we have this model boat that travels, and the key lands and hits it. And so we want to know the speed of the boat. in order for the key to hit it. So let's label a few letters. First of all, let me just change a couple things here. I will make the water blue, but I'm gonna make the boat red so I can distinguish letter colors when I'm doing this problem. So here. So what we're gonna say is x naught of the boat is 0, x final of the boat is 12, and here we have y of the boat, y naught of the boat is 0. Sorry, is y naught of the boat is 45 meters because we start off high in the air, and then y final is going to be 0. And of course, remember that acceleration is g, which is negative 9.8 meters per second squared. So now, we want to know what's going on with the speed of the boat. So here's what we're saying. In the time it takes the key to fall, that's the same time it takes the boat to catch the key. So let's do the boat equation, or the key equation. Y equals 1/2 gt squared plus 0 plus 45. And let's be clear, flush, it would be 0 equals 1/2 times negative 9.8 times t squared plus 45. And I'm going to do a bit of rounding here. I'm going to round 9.8 to 10. And so what that means is I end up getting negative 45 equals negative 5t squared. And so I get t is about 3 seconds. Now that's the thing that I'll use to get the speed for the boat. So I have time of 3 seconds. So for the boat, what I'll use is x equals v naught t plus x naught. And so I have 12 equals v of the boat times t, which is 3, plus 0. And so that gives me v of the boat equals 4 meters per second. All right. Now, number 7. This is actually a really good question, and I'm glad I asked it. It says a stone is dropped into a river, and then another stone is thrown vertically down 1 second after the first stone is dropped. The stones strike the water at the same time. What is the initial speed of the second stone? So let's do an equation for each stone. So I have stone 1, and I have its y naught is 43.9 meters per second, and its y is 0. So that's one thing. And then we have second stone, and I'll draw it in blue, and the water, and its y naught is also 43.9 meters. Sorry, I have meters per second, and it's not. It's meters. It's a height. And then y equals 43.9 meters. Now, they strike the water at the same time. You want to know what the speed of the second stone is for that to happen. So let's go ahead and do that math now. So with that in mind, let's just solve some things for the first stone. So let's get its time to hit the water. So I have y equals 1/2 gt squared. I don't have an initial speed, and I do have an initial position of 43.9, and I also know that my final position is 0. So I end up getting negative 43.9 equals negative 4.9 times t squared. And I can actually go ahead and solve for t and get that now. I'm going to round a lot here. I get that t is about 3 seconds. So if it takes stone 1 3 seconds to hit the water, that means t2 takes 2 seconds. So now I'm going to set up the equation for stone 2. So I get y equals 1/2 times negative 9.8 times 2 seconds squared, plus I have v naught of the second stone, which I don't know, times 2 plus 43.9. And this is 0. So now what I can do is I can rearrange all this math. This is the only unknown. So I'm going to go ahead and solve that, and when I do that, I'll get the answer. It is, in fact, negative 12.15 meters per second. Negative because it's going downwards. So that finishes up exam 2. And in the next little thing, we'll do the exam 2 retake in the next set of videos.